1 year ago, I built this sub counter, YouTube states counter, and it works, but it takes a lot of time to view everything. So this will be the new version. It's using I2C display LCD and Wemos D1 Mini, and you will need D1 to be connected to CCL, D2 to SDA, ground to ground, and 5 volts to VCN. So that's basically it. We will build a new case. Last time I didn't have a 3D printer, so I had to do it myself out of plastic. But now with the help of Almighty Bamboo, we will have a proper case for it. I will share also the files for the case. Now let's solder. We will need 4 wires. As I said, D1 to SCL, D2 to SDA, and ground to ground VCN to 5 volts. I'm not enjoying this display very much. I saw some comments on the Arduino forum that it might flicker if you don't solder the ground properly. No, I'm pretty sure the ground is soldered as expected, but it's still flickering from time to time, and this is not related to the refresh that I'm doing with the API, because it flickers just super often. I tried increasing the waiting time, the delays. This doesn't change, so I guess it's just related to these displays. I won't record much from the soldering process because it was a weird angle, so I didn't properly record it. Some shrinking tubes, and you know the story. I will share this case, the entire case for the entire build on Maker's Vault, and I'm using 8 screws that I had from spare laptops. So I'm not very sure. I will guess they're M2 or something like that. Most probably M2s. So it's smaller than the previous one, more sturdy, of course. And the procedure to get the API is the same. You have to go to Google Cloud YouTube API, create a new project, click on create. You have to wait a little for the project to be created, then you will have to select that project once it's created. Go to APIs and services. Here you should click on create, and here you can search for YouTube API, the B3 one, so data API B3. Enable it. If you did this last time, you don't need to do it anymore, but if you're first time here and want to build this version, you need to enable it. Once it's enabled, you need to create some credentials. So an API key, more specifically. So once it's created, you can copy it and save it somewhere. You can have it in for future projects, and just going to YouTube Studio, you can copy your channel URL So this is, I'm using now the liquid crystal library, and this is the only version that I found working. And I will mention this, the creators, so just for you to know, because if you are using a wrong library, you'll just get stuck with this. So let me write the library creators here, so you can know which one to select. Here we have 60,000, which means 1 minute. 1000 means 1 second, so we have 60 seconds. Here you can select what to show. Firstly, it's the first character, first row, first character, second row. These details will all only be available on serial monitor, because we are serial printing them. And this is what's shown on the LCD. So firstly, I'm sending 16 blank spaces to each row, because if we are clearing the display, then it will flicker. So it already flickers. If I'm doing that, it will be an enormous amount of flickering, so we don't want that. Okay. I think that's pretty much about the code. We can just upload it. And this is what you have before uploading it. We'll have some warnings, but they are not messing up with the code itself. But those are just warnings, not errors. Now we have the YouTube states and PythonEatsSQuirreL. So here I waited for a couple of minutes before realizing that I uploaded the code without the credentials, Wi-Fi or API or YouTube channel. So I just added the credentials now and upload it again. So you need to keep in mind that you have to remove those X's and add your credentials to the code before uploading. Now you can see it's connected and it's listed the IP. This is the IP of the Wemos Xeon Mini. And we can see there the states. And we have them also on the LCD. One thing with this LCD is you might need to adjust the brightness and the contrast, because I think that this one is just turned all the way to the max. So this is why it's too bright, and also the contrast is too big for this device. So you have a little screw at the back of the LCD, and you just have to turn it counterclockwise just a bit. As you can see, the light has just dimmed a little, and now it's more visible. So compared to the previous project, I think this one is much, I won't say portable, but it's much sturdy for sure. I still have some flickering on the LCD. I'm not really sure why do I still have it, but I don't mind having it. I don't have the full channel name here because I can only fit 16 characters. So okay. Hope you've enjoyed it. This is all for today. Please subscribe to this channel if you're not yet a subscriber, and see you in the next video. Cheers.